We know the relation between collector current and emitter current, and now we can easily understand the basic amplifying action of transistor. I am using common base configuration for this purpose, and you can see I have not shown the DC biasing in this figure because we are interested in AC response. I am using NPN transistor, and considering the active mode of operation, the emitter current is the leaving current, i.e. the emitter current is the leaving current, the base current is the entering current, IB is the entering current, and the collector current, IC, is also the entering current. VI is the input voltage and it is equal to 200 millivolts. RL is the load resistance, and let's say it is equal to 5 kilo ohms, and we need to calculate the output voltage VO. Let's say the input resistance offered by the transistor is Ri and the output resistance offered by the transistor is Ro. In the input characteristics of transistor, you can see slope is large, slope is nearly equal to 90 degree, and slope is equal to 1 by input resistance. So when slope is large, this implies input resistance is small. So the input resistance of transistor is very small, and I will consider a common value of 20 ohms. So Ri is equal to 20 ohms. In the same way, we will analyze the output characteristics of transistor. In the output characteristics, you can see slope is nearly equal to 0, and when slope is low, this implies the output resistance is high. So the output resistance offered by the transistor is very large, and I will consider a common value of 1 mega ohms. The output resistance is equal to 1 mega ohms, or we can say it is equal to 100 kilo ohms. So these are the values of input resistance and output resistance, and now we can easily calculate the output voltage VO. We know input voltage is equal to the input voltage VI is equal to the input current multiplied by the input resistance. Input current is the emitter current, so VI is equal to IE multiplied by the input resistance. This implies the emitter current is equal to the input voltage divided by the input resistance. The input voltage is equal to 200 millivolts. So we have 200 millivolts divided by 20 ohms, and it is equal to 10 milliamps. And we already know the collector current IC is equal to alpha times IE plus ICBO. We can neglect ICBO, so IC is nearly equal to alpha times IE. Alpha is from 0.95 to 0.98, which is nearly equal to 1. So IC is nearly equal to IE. IE is equal to 10 milliamps. This implies the collector current is also equal to 10 milliamps. The collector current is the output current, and now we can calculate the output voltage. The output voltage VO is equal to IC multiplied by the load resistance RL. IC is 10 milliamps and the load resistance is 5 kilo ohms. When you solve this, you will have 50 volts. So this is the value of output voltage, and this is our answer. You can see the input voltage was 200 millivolts and the output voltage is 50 volts. So definitely there is amplification, and now we will calculate the voltage amplification. The voltage amplification, it is denoted by A sub V, and it is equal to the output voltage divided by the input voltage. The output voltage is equal to 50 volts, and the input voltage is equal to 200 millivolts. When you solve this, you will have 50. So the output voltage is 50 times the input voltage, or we can say that the input voltage is amplified 50 times in this configuration. The voltage amplification for common base configuration varies from 50 to 300. This is for the voltage amplification, and in case of current amplification, it is always less than 1, because current amplification is IC divided by IE. IC is equal to alpha times IE. Alpha is from 0.95 to 0.99. This means IC is smaller than IE, and because of this the amplification of current is always less than 1. So this is all for this lecture. If you have any doubt, you may ask in the comment section, and you now know how the transistor amplifies the input voltage. I will end this lecture here. See you in the next one.